Hey folks, welcome back to CSE 1322. This is module number 8, part 4. We're going to talk today about a new data structure called HashMaps. So far in this module, you've learned about the different data structures. So we've seen arrays and array lists. Those have been with us since the beginning. We've also talked about linked lists, stacks, queues, priority queues, binary search trees, and trees in general, and graphs. So the last one we're going to talk about is called a hash map. I will say that this is called different things in different languages, but every language has a version of it. So sometimes you'll see it referred to online by other names. Java calls it a hash map. C Sharp calls it a dictionary. C++ calls it a map. Python called it a dictionary or a dict, and PHP calls it an array. They all share the same property, which is that they have keys and values, and you can't have duplicate keys. So let's take a look at the Java implementation. You're going to import Java util hashmap. And just like many of the other things we create, it's hashmap, a variable name equals new hashmap. In the angle brackets, you're going to put in two types. The first type is the type of the key, and the second type is the type of the value. So, for example, in this case, you might use integer string, or you might use double dog. So it just depends on what it is that you're trying to make. In all cases, it's going to be an object, so it's going to have to be the capitalized version, so capital, double, or integer spelled out with a capital I. So, what do you use a hash map for? Well, a couple of examples are sometimes you want to be able to associate two things together inside of your program. And so, for example, you might want to keep track of the colors of vegetables or fruits. And so, like, you might want to have fruits. So, you would say fruits, fruit colors dot put, banana is yellow, apple is green. And that's done with this syntax. So, this would be an example of a hash map with two strings. The first string is the key, which is the fruit name. The other value is the other thing is the value, which in this case is also a string, and that's the color. You might also want to be able to keep track of ages. So you might say something like put John 19, Jane 18. This uses a hash map with a string as the key and a integer as the value. You could also want to keep track of the months, which is the opposite of that. This is going to be an integer and a string. So 1 is January, 2 is February. This allows you to store data and then look it up very quickly later on, which is really useful. All right, so some of the methods that you have, you get the ones that you pretty much always get. You get a remove, a get, a clear, and a size. So, for example, you can say remove and then apple, which will remove the key that is apple and its associated value. If you get apple, it'll tell you green, and assuming that you stored the values. Clear removes all the keys, and size tells you how many items are in there. You can iterate through a list, through a hash map in this case, by using a for each loop. So you'll remember the syntax for that is for int month in months.keyset. So this gives you all the keys as a set, and that can be iterated over. And then one at a time, the key, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, is going to be assigned to month number. And then you can print out month num, or you could print out the value associated with it. You can also do it based on the values. So for each string in the values, this would print out January, February, March, all the way up to December. So you can do it either way. Printing all of the values in a hash map. So again, same idea here. You put in some various things, and then you're going to use a for each loop to pull them out. So for example, pull out all of the keys, which in this case is going to be January, February, March, April, May, and all the way up to December. One at a time, assign them to month name. And then we're going to be able to print out month plus month name is month number, and then months.get the month name, which will turn back the value, which is the 1 or the 2. So hash maps are really, really useful. Um, they are they're used to do a lot of different things. So, like the example with the months is a common one that I've personally had to code a number of times, where sometimes people will give you the month as a number and sometimes they'll give it to you as a name, but you need to store it one way in the back end. So you need to have a map that tells you this number is this month, or vice versa if they give you the month name to be able to look it up to the number. Um, so, how do these relate to arrays? Well, the similarities with arrays is that an array has a key and a value, right? So the key is hard coded in an array to be 0 up through the number. Whereas with a hash map or a dictionary, as they're sometimes called, you can select what the key is. So, one way to think about it, which is kind of a goofy way to think about it, is it's like you have an array, but you can specify what the name is of each of the cells rather than it always being 0, 1, 2, 3, 4. The value that's in the cell is, in the case of the colors, it's the color of each fruit. And the actual key is the name of the fruit. So that's why it's sometimes called an associated array, or just a dictionary or a hash map. Again, all the same kinds of names. The differences are arrays always have a fixed size, whereas hash maps can grow and shrink dynamically. And the cells are whatever you want them to be, as opposed to being hard coded with the numbers. Okay, so common uses. Imagine you have an array of doubles with student grades, and you would like to count how many people got A's, B's, C's, D's, and F's. We'll write a method which takes in an array of doubles, we'll iterate over the array, and using a condition, we'll just check each grade to see where it fell. So if it's greater than 89.5, greater than or equal to, hopefully, then we're going to put in an A into the hash map. And basically what we're doing is we're adding 1 to the hash map at position A. And that tells us there's one more student who got an A. If it's greater than 79.5, we add 1 to the hash map at position B, and so on. At the end, we simply print it out, and it'll tell us how many people got A's, how many people got B's, how many people got C's, and so on. So that's a very common use of a hash map, is that you just need to count something in there. So here's an example. So we're putting in that there are 0 A's, 0 B's, 0 C's, and D's and F's, and then we use a loop to go through all of the grades that are presumably stored in this grades array. And we're checking each one, and we're just simply adding the value of 1 to each one of the cells when we see that grade. Um, so let's talk about the big O of a hash map. Well, generally looking up something in a hash map or a dictionary is considered order 1. So if you say, give me the color that is a banana, the answer can be retrieved, hopefully, in order 1. It's much like looking up something in an array. But in reality, under the hood, there's a lot of detail as to how that's actually being accomplished. Usually, what happens is there is literally a big array. And when you try to store something in banana, it just converts banana into a number, and then it puts the value into that cell of the array. This is called a hash function, where it's hashing the word banana into a number, and then you store the value in there. The problem with the hash function is you have to be careful that there are no collisions. A collision is when banana happens to come out to number 72, but also for some strange reason, grape happens to turn out to be 72 as well. So if the hash function is not ideal, then you can have collisions, and those collisions cause problems because you can only store one thing in cell 72. So usually the way around that is you put one of them in 72 and you put the other one in 73. And then you just kind of have to remember it's off by 1 for that. So that's the implementation, which is beyond the scope of this class. You'll deal with this when you take data structures, but that's basically how they're implemented. The problem is coming up with a hash function that works well for all of the keys, and gives you a good lookup. So the reality is it's not always going to be order 1 to get data back out of the hash map, because sometimes you have to actually go search in the neighboring cells or search in a linked list inside of each cell to go find the actual value for grape, because the hash didn't send you to exactly the right place. Okay, so that completes this lecture. It's a real short one. We just wanted you to be aware that this data structure exists. Hash maps are very useful in the real world, and so you'll actually find yourself using them quite often. You may have used them in 1321, just because you may have needed to do a lookup in a cell based on a value. So now you know they exist, and you know how to use them in Java, and that completes our data structure module, which was module number 8. In the next module, we're going to switch languages and start talking about C#, which is a whole new language. So exciting stuff to come, and I will see you guys all there.